Ladies and gentlemen, welcome to our webinar today. We thank you very much for your interest. Today we wish to talk to you about marking medical instruments, tools or devices made out of medical steel or other metals. We would like to introduce PERMAblack to you. PERMAblack is a marking process developed by Photon Energy. Although it is not a brand new technology, it has been tested and proven in the field. In this webinar, we will give you the technological and financial benefits as well as a general overview of the product. But first, I would like to introduce myself. My name is Hans-Peter Wunde and I am responsible for the sale of our products in the United States. Although I have only been with Photon Energy for 4.5 years, I have been in the laser and laser systems field for over 25 years in both sales and service roles. Photon Energy is a small to medium-sized company headquartered in the south part of Germany, more specifically in Bavaria, near the city of Nuremberg. We develop and manufacture laser sources and complete laser workstations for materials processing 2D and 2.5D. The company is certified according to ISO 9001:2015. Our target customers are in the production industry rather than in research, and our focus is on product robustness and reliability. At the moment, most of our products are sold to the medical market, mainly for corrosion-free marking of surgical tools, which we will go over in this webinar. But we also sell products to the semiconductor industry, machine tool industry, and various high-precision micromachining industries with applications such as drilling, cutting, scribing, dicing, surface structuring, or display glass cutting. Our product portfolio can be divided into 3 segments. On the left you see our laser sources, nano and ultra-short pulsed lasers. In the center we have a special product category for machine builders. We sell the laser source combined with a beam delivery system as a fixed package covering all the laser and optics part. On the right side we see the laser system segment. We do not offer simply a laser marker, but a complete solution to meet your laser marking needs. We provide a comprehensive package of marking machine, customer-specific software, camera options, and various automation options. But I'm going to touch that topic again at the end of the presentation. Let's go back to the original topic of the webinar, which is marking. Why do people mark things? One of the most common applications is branding. Companies mark their products with logos, labels, and descriptions. In the case of surgical tools or medical devices in general, product identification and traceability are becoming very important, especially since the US Food and Drug Administration released their UDI regulations. Although identification and traceability are very important in the medical industry, many companies in other fields are starting to track and identify their products using laser marks. This is especially true in industries with counterfeiting problems. Then we have technical markings like scales or other kind of marks, which I will call functional markings. Let's take a quick moment to go over UDI regulation. So UDI stands for Unique Device Identification, and the FDA has released the final rules for UDI on September 24th, 2013. Here on this slide we see the deadlines for the implementation. The UDI regulations affect all medical devices, but we are referring only to devices that are intended to be used more than once and must be reprocessed in some way before each use. Let's have a closer look and see what those regulations have to say regarding marking. First, it concerns all medical devices of class 1, 2, and 3. Second, it says reusable products must carry the UDI medium on the product itself. The UDI medium must be applied permanently to any product that requires cleaning, disinfection, sterilization, or preparation between uses. The UDI code must be readable during the entire expected lifetime of the product. So let me summarize the important points. The marking has to be on the part itself, it must not be removable, it must be well readable, and it must not show any significant deterioration throughout the entire expected lifetime of the product. The picture shows an example. The UDI marking consists of a data matrix code and an alphanumeric code known as GTIN code. The code contains information on the product's category, manufacturer information, serial number, etc. For marking such products, people use typically lasers, but making marks that fit these criteria and last the lifetime of the product is difficult with a conventional laser on materials such as stainless steel. Luckily, we have an excellent solution, PERMAblack. But in order to understand the benefits of our solution, I would like to explain first how the marking is already being done by most medical device manufacturers. There are many different types of medical grade steel, but they all require additional corrosion protection in order to be corrosion proof. The devices are placed in a citric or nitric solution for a short amount of time. This process of protecting against corrosion is called passivation. To mark surgical instruments or devices made out of stainless steel, most people use standard or conventional lasers, often so-called fiber lasers or YAG lasers. The marking directly after the laser marking process actually may look excellent. However, the material will corrode at the marking even if the tool has been passivated beforehand. The conventional laser is simply removing the corrosion protection that was already there. Consequently, the instrument has to be passivated again after the laser marking process is finished. Unfortunately, the passivation process also affects the marking quality. The rule is, the longer the passivation, the better the corrosion protection, but the worse the resulting marking quality. This passivation actually turns out to be very critical because the timing has to be very precise in order to achieve sufficient corrosion protection and marking quality. Many companies suffer from high rejects due to unsuccessful passivation. Some companies choose to passivate in two steps. First, thorough passivation prior to laser marking to achieve a good base corrosion protection, and then a second passivation to give a little corrosion protection to the laser marked area. One way or another, the result is a compromise, and companies are facing losses due to unsuccessful passivation. We spoke about what happens at the manufacturer. Now let's speak about the end user. Many hospitals and clinics suffer from these issues. Instruments must be cleaned and sterilized after each use. Sterilization is done in an apparatus known as an autoclave, and it is this autoclaving process which again affects the laser marking. The marking does not corrode, but it does lose contrast. After several preparation cycles, the marking will have faded significantly. This means clinics must either buy new instruments or have them re-laser marked. Regardless, this costs them money. Both issues are very well known among manufacturers, but not considered a huge problem. At least if you talk to them officially, no one will admit to having a problem. I think this is basically due to the fact that the conventional laser marking method is well established and there have been very few recent improvements to the process. But if we meet with a customer in a more informal setting, like for lunch or dinner, then they may have a different opinion. There are these two pain points that people tolerate just because they have no solution. The good news is, now there is a remedy. Photon Energy's PERMAblack process uses a special ultra-short pulsed laser. Hang on, you may say. Isn't that also just laser marking? After everything I have said so far, you might have expected something different. Well, the laser we use is different to standard lasers used for marking applications. Our laser emits pulses with an incredibly short pulse duration, no more than a few picoseconds. But it makes a big difference, because the interaction of the laser light with material is different from a physics point of view. So the result is also different. Unlike conventional lasers, the ultra-short pulsed laser does not create any heat on or inside your workpiece. It is a so-called cold interaction. Do you know how short a picosecond is? It is 1 second divided by 1 million and then again by 1 million. Or as comparison, if the distance to the moon is 1 second, 1 picosecond would be 0.4 millimeters. So again, we mark using a laser, but the laser is very different to conventional marking lasers. But let's leave the technology again and let's go back to the PERMAblack marking process. Rather than describing to you the physics of this process, I would like to show you the benefits of PERMAblack. A moment ago we heard about conventional laser markings that bleach during passivation. Well, this is what happens if you passivate PERMAblack markings. Nothing happens. On the test shown here, we have varied the duration of passivation, and no matter how long we passivate, the marking does not fade away. Now, to be honest, if you look very closely, there may be some very small degradation at the beginning, but there is no significant deterioration afterwards. So you can passivate for 1 hour or more, and the markings will be still deep black and have excellent sharp contours. For most customers, this has actually been the primary motivation for buying our systems. Now let's talk about corrosion resistance. Unlike conventional laser markings, PERMAblack markings are completely corrosion resistant. The picture shows a PERMAblack marking after a 24-hour salt spray test. No corrosion at all can be seen. Now what does that mean? First, you do not need to passivate after laser marking. You only must perform a thorough base passivation of the instrument and then laser mark it. That's it. And second, if you have the requirement from your customer to passivate after laser marking, you can do so as well. But you can save the thorough base passivation before laser marking and passivate properly after laser marking without losing marking quality. This is one of the main differences between PERMAblack and conventional laser markers. How proven is the technology, you may ask? We, and especially our customers, are performing long-term tests, one of which has reached more than 500 preparation cycles without any deterioration of the PERMAblack mark. Another helpful property of a PERMAblack mark is its visibility. A conventional laser mark will be difficult to see at certain viewing angles. See the top markings for reference. The lower markings are PERMAblack and they can be seen clearly under every viewing angle. Now here we show you a few little videos where we rotate parts which have been marked by PERMAblack, and as you can see, the data matrix code can be seen basically from all viewing angles. This property improves the reading process immensely, Scanning data matrix codes becomes easier and more reliable. The same is true for scale markings. It is easier for the doctor to see scale markings under difficult illumination with PERMAblack. Now we are going to look at some benefits related to heat. On the left side, we have a conventional laser hitting material. As you can see, the laser not only affects the surface, but also the bulk material underneath. The red area is called the heat-affected zone, or haze. The temperature in this red area can reach a couple hundred of degrees Celsius easily and can change the material's property. On the right side, we see an ultra-short pulsed laser hitting the material. As you can see, there is no heat-affected zone. The laser light hits the surface without creating heat underneath due to the much shorter pulse duration. But let's leave the realm of science again and look at the benefits of this cold process. Here are a few common side effects. Discoloration, for example, surface distortion, deformation of thin material, bulk material changes like its stoichiometric composition or crystalline structure or lattice arrangement, changes of material properties. The last one on this list is not actually a side effect but a primary effect. It is surface structuring for improved osseointegration. Here is an example for material changes due to heat created by the laser. I'm using material published in the Archives of Orthopedic and Trauma Surgery by Klüss and Steinhauser. Their studies revealed that the crack of the hip stem originated from the laser marking, and further studies showed that the material just underneath the laser marking had been slightly modified due to the heat created by the laser. A conventional laser marking system had been used for this marking. Something like this would not happen with PERMAblack. Instead, the laser can be used to microstructure the surface to improve osseointegration. The process is similar to the PERMAblack process. It is based on the same laser source and done on the same machine. On this slide, we see an example of material deformation and discoloration. The material here is nitinol S, which is used in certain medical applications because of its memory effect. A conventional laser would influence this memory effect. PERMAblack will not. On the lower picture, you can see how the back side of this metal shows discoloration and deformation. Miniaturization is another topic that many customers ask about. The PERMAblack process gives a very high contrast, clear and sharp edges, as well as small laser spot sizes. That allows the creation of very small structures with high resolution. The smallest data matrix code which we offer is 1.8 by 1.8 millimeter. But this dimension is the lower limit given by the GS1 standard and is limited by the DMC reading equipment available on the market. The PERMAblack process is capable of further miniaturization, however. Finally, the speed of the system. Since the laser is not heating up material, it can mark quite fast. Our customers have noticed a difference of about 20% compared to conventional markers. This effect may or may not matter for you. It all depends on your production volume. The video you see here shows a typical PERMAblack marking process. Now here comes the important part, the money. PERMAblack gives you financial advantages at several stages of production. Eliminating the issue of rejection due to unsuccessful passivation is a big win for many customers. But a lot of customers also appreciate the fact that the passivation process is much less critical and therefore easier to control. Besides the control of the process, the customers can reduce the numbers of passivation cycles down from 2 to 1. They can passivate either before or after the laser marking process, which gives them a lot of flexibility. Most customers must passivate in 2 steps, one before and one after conventional laser marking. This is not the case with PERMAblack. One passivation cycle is enough, and you can choose to do it before or after laser marking. To be honest, the laser is more expensive than a conventional marking laser. But if you consider the big picture, it makes more sense. According to our customers in Germany, it amortizes within 1 to 2 years. In many cases, you get product improvements only at higher costs. This is not true for the PERMAblack marker when you consider purchasing costs and production costs together. So this was the financial benefit at the device manufacturer, but we also have benefits at hospitals and clinics, which we see on the next slide. Conventional laser marks fade during each preparation cycle a bit, so clinics and hospitals have to replace instruments or have them re-laser marked after some time. PERMAblack marks do not degrade in the autoclave, and hence the instrument does not need to be replaced or remarked. PERMAblack marks are permanent, as the name indicates, so clinics and hospitals save money as well. Validation. This can be a big headache for many manufacturers. Well, in case of PERMAblack, we can take a part of the burden off your shoulders. We have more than 50 systems in the field for marking surgical instruments, and all those customers had to go through the validation process. None of them were rejected. We know how to arrange the validation, and we support our customers regarding the validation by giving support throughout that process. So there is no risk for you. Now I am finished with the PERMAblack section and would like to continue giving an overview of our PERMAblack marking machine itself. You see here our standard base workstation. It is also called simply workstation. You have a sliding door that you can open. You place the workpiece inside and close the door again. Closing the door will activate the laser marking process itself. The machine comes with our standard software, which is very intuitive and easy to use. For our medical customers, we have several options dedicated to the medical market, like a special UDI software, assistance regarding validation, or integration into your ERP system by providing proper interfaces. Let's look at some of the hardware options. Usually the instruments are very small and the standard workstation will do just fine. But if you have larger pieces, such as a sterile containers, for example, then we can also offer a machine with a larger cabin like the workstation XXL. On top of that, we have several mechanical options like XY table or rotary axis. We also offer several camera options for observation, marking verifications, or workpiece recognition, also known as shape detection. Software-wise, we have a few options. We offer ERP integration as well as a customized graphic user interface. Most importantly, however, we offer a UDI software package. The package includes a special restricted user interface to protect from unwanted changes, data input, data preparation. This is compiling the GTIN code and the DMC, control over the laser marking process itself, verification of the DMC by reading it through a separate camera system, data output that can upload the results into the customer's database, for example. Finally, it prepares data for an audit trail. So as you see, we do not offer only a laser marker, but a comprehensive package or complete solution to our customer. But going through all options and properties of our system would take too long for this webinar, so I will stop describing our system here and instead show a few more examples. So on this slide we see an instrument with a data matrix code and an alphanumeric text in the center. Here we have 3 drill bits with a matchstick for size comparison. You notice our company logo on the shaft. Marking curved surfaces, even with small curvature, is no problem. On this picture we see again a drill bit on the left side and a magnified QR code on the right side. On this slide we have anodized aluminum in 3 different colors. The interesting part is the marking is actually happening underneath the anodization layer. So the anodization layer remains in place and keeps its protective function. A conventional laser would simply remove the anodization layer. PERMAblack does not. Here we see marking of titanium alloys with PERMAblack. So you see it is not restricted to only stainless steel. It works also extremely well with titanium and other metals. This slide shows a few markings on plastic. The marking is no longer deep black as you see. The marking effect is also different, but it is the same laser and the same machine. That means you can use the machine to mark metals and plastics. And here we have a few ceramic examples. Again, no black marking, but it is a marking. Now we have reached the end of our presentation. I would like to thank you very much for your time. If you have further questions, you can post them now or contact us via email and phone or meet us, Chris and myself, at MD&M West in Anaheim next week. At this point, I also like to thank Jack Fanning with Kearney Machinery for organizing the webinar technically.